There's a machine that could do this to your phone. Not melt it, erase it. The outlet in your wall carries about 15 amps. A lightning bolt carries around 30,000. This machine fires 26 million. At its heart sits a cage of wires, each a tenth the width of a human hair. The whole target is the size of a spool of thread. Fire it, and the wires vaporize. A magnetic field crushes the cloud inward, fast enough to fly a plane from New York to San Francisco in seconds, down to the width of a pencil lead. For a few billionths of a second, it makes plasma hotter than the core of the sun. So what is this thing? From the outside, it looks like an old high school gym. Inside, dozens of generators dump their charge into cables as thick as a Volkswagen Beetle. The result, the most powerful X-ray generator on Earth. But here's the real question. Why would anyone build a star on Earth? Two parts. First, we follow the electricity through the machine. Then, why anyone needs a star on Earth? Stick around. Let's follow the power. It starts slow. For about 2 minutes, ordinary wall current trickles in, charging a ring of capacitors. Then dozens of Marx generators fire at once, unleashing it all in a heartbeat down those beetle-thick cables. Now, some of those cables are insulated by water. Remember the arcs from the beginning? That's water doing its job. Where it meets the air, the charge leaps across as a flashover. Deeper in, the current passes through nested steel cones weighing about 10 tons. Every shot takes its toll, so crews refurbish this whole section afterward. And the target itself? A technician builds it by hand, setting each hair-thin wire with tweezers. But nobody builds Earth's most powerful X-ray generator just to make sparks. The current rips through those wires 20,000 times faster than lightning. They implode into a thread of plasma. For about 100 nanoseconds, the machine puts out more electrical power than every power plant on Earth combined. That surge erupts as X-rays, 350 trillion watts of them. You might think a machine like this needs its own power plant. It doesn't. Each shot uses about the energy of a 100-watt bulb left on for 2 days. So how does a light bulb outpower the planet? The trick isn't energy, it's time. Think of a camera flash, same battery as a flashlight, but it dumps everything at once. This machine is far more extreme, but the idea is the same. So why build it? Its main mission is guarding the nuclear stockpile. Without live weapons testing, the US recreates those conditions here, in miniature. That tiny wire target lets scientists study matter inside a warhead, or inside a star. Now, here's the strangest thing this machine ever did. Back in 2006, in one experiment, 20 million amps tore through an array of steel wires. The plasma it produced passed 2 billion degrees, over 100 times hotter than the sun's core. You might think nothing on Earth could top the sun. For anything lasting more than a microsecond, you'd be right. But here's the twist. That plasma should have collapsed and cooled. Instead, for about 10 billionths of a second, some unknown energy kept pushing back. At first, we were disbelieving, said project lead Chris Deeney. They repeated it many times just to be sure it was real. That heat points to something bigger, fusion. Crush hydrogen fuel the same way, and you chase the reaction that powers the sun. They've even recreated the conditions at the surface of a dead star, a white dwarf, on a lab bench. Everything you just watched was written, animated, and rendered on our own machines. If it was worth it, a like takes 1 second, and it genuinely helps. So look again. Those arcs from the start? That's this whole machine, firing, all of it from a light bulb's worth of energy. It was never about energy. It was about time. And Z is only the beginning. As one lead scientist put it, there's another decade of exciting research ahead. Next time we open up another machine just as extreme. This is Machines That Never Sleep, where we take apart the machines quietly running our world. Subscribe, and we'll see you inside the next one.